In this video, we will discuss the graphical method for the convolution. So we have an example for that. For example, if a signal y of t is equals to x of t convolution with h of t, and x of t is the input which is exponential minus 2 ut, and h of t is the impulse response which is the unit step that ut plus 2. So the first step that you need to change the limits of y of t. So where x of t is replaced with x of tau, and similarly the x-axis t is replaced with tau, e raised to a minus 2 tau and u tau, and similarly this one as well, that is h of tau and then tau. The second is the folding, that you need to fold the h of t. So if folding means the reflection or the time reversal property that we have already studied in our previous topic. So the folding of this h of t will be on the other side, that is the positive side, which is the reflection or the image. So that is h of minus t. The third property is the shifting. So h of t minus tau, or you can say that h of minus tau plus t. So basically you are shifting that signal with any particular value t, and we don't know what is the value of t, so we just put t plus 2 as a shift. So and we represent that signal h of t minus tau. So that is just the shift. So that is t plus tau. So that is a shift, and the shift is represented at t plus 2. The fourth one is the multiplication, that you need to multiply the region where the two signals are overlap, like h of t minus tau overlap with the input signal x of tau. So you can see that the y of t, because you know that the signals are overlap where the lower limit is 0 and the upper limit is t plus 2. At that place the both signal will be overlap, like y of t is equals to integral from 0 to t plus 2 e raised to a minus 2 tau u tau, and the unit step value, the amplitude is 1 multiplied by 1. So if you take the integral of e raised to a minus 2 tau, so the answer will be equals to e raised to a minus 2 tau divided by minus 2, where the limits from 0 to t plus 2. So if you insert the limit, then you will end up with the answer y of t is equals to minus 1 by 2 e raised to a minus 2 t plus 2 minus 1. We also have other method in order to solve the convolution using the graphical method. So we have an example like the input signal is equals to e raised to minus 3t ut, where the impulse response is equals to ut plus 3, and we need to calculate the convolution of these two signals, where y of t is equals to x of t convolution h of t, or you can write the integral formula from minus infinity to infinity x of tau h of t minus tau d tau. The first step is plotting the x of t and h of tau. So x of tau is basically the multiplication of the decaying exponential function with the unit step signal. So if you multiply the decaying exponential signal with the unit step, the resulting graph will looks like this. And you know the h of t is basically the shifted version, and the shift you can calculate by equating the t plus 3 is equals to 0 and t is equals to minus 3, so on the negative side. So t is equals to minus 3, and then you can plot the unit step. The second step, that you need to plot the shifting h of t minus tau, or you can say h of minus tau plus t. So for that, first you need to plot the time reversal signal of h of tau, which is h of minus tau. So time reversal is just the shifting of that signal on the positive x-axis, or you can say this is the reflected version of h of tau. So h of minus tau will look like this, and then you need to plot the shifted version of that signal. So where h of minus tau plus t will be t plus 3, because you don't know what is the value of t, so you just write t plus 3 and the shift is looks like that. Then after that you need to calculate what are the overlapping region and where the non-overlapping region. So we will discuss the non-overlapping region. So the non-overlapping region will be the region where t plus 3 less than 0. Like we have a input signal from 0 to infinity, but we have the impulse response, which is the unit step signal, or you can say the shifted version. So that is basically from minus t from minus 3 to infinity. So these two are non-overlapping region, so the answer will be 0 because we don't have overlapping region. So that is why their convolution will be equals to 0. The fourth one is the overlapping region, where the value of the limits will be t plus 3 bigger than 0. So if that signal, like the impulse response, will be bigger than 0, or you can say if the value of t is greater than 3. If the value of t is greater than 3, then you can write that signal y of t is equals to the integral from 0 to t plus 3 e raised to power minus 3t, and you know u tau is equals to 1, so that is why you don't need to write 1. And you know the integral of e raised to power minus 3 tau is equals to minus 1 by 3 e raised to power minus 3 tau, and the limits from 0 to t plus 3. So if you insert these limits into this value, then the answer will be minus 1 over 3 e raised to power minus 3 t plus 3 minus 1. And you can say that you can write the answer in 2 times, like y of t is equals to 0 if the impulse response, or you can say if t plus 3 less than 0, and the value of y of t is equals to minus 1 over 3 e raised to minus 3t plus 3 minus 1 if t plus 3 is bigger than 0. Similarly, we have another example, like if x of t is equals to ut plus 2 and h of t is equals to ut minus 3, and we need to calculate the convolution of x of t and h of t using these two formula, or you can use the graphical method. So in the graphical method, the first step is that you need to plot h of t and x of tau. So the x of tau you can plot by using this equation. So from where you can see that the value of t is equals to minus 2. So the value of t is minus 2, the shifted version on the left hand side, and it is a basically unit step function. And similarly, the h of tau is also a shifted version, and the shift is on the right hand side where t is equals to 3. So similarly you can plot that signal as well. And then the second, you need to plot the time reversal and the shifted version of h of tau. So the time reversal of h of tau is just the image of that signal, so which will look like this one, and the shifted version of that signal will look like this one, t minus 3. And then you need to calculate the overlapping and non-overlapping region. Third one is the non-overlapping region. The non-overlapping region will be the region when t minus 3 will be less than minus 2, or you can say that t is less than 1. Like if the 3 will be on the other side, then it will be positive, so the t less than 1. So the graph will look like this one, t minus 3, and the other signal will start from minus 2. So that is why there is no overlapping region. So that is why the value of yt is equals to 0. Fourth one is the overlapping region. So overlapping region where t minus 3 greater than minus 2. So if it's greater than minus 2, then you can see the region will be overlapped, and then you can calculate the value. Then you can calculate the value of y of t, which is equals to the integral whose limits start from minus 2 to t minus 3, and you know the amplitude of unit step is 1, so d tau. So that is the integral of 1 is tau, and you insert the limit minus 2 to t minus 3, and the answer of yt is equals to t minus 1. So that is why you have the value of yt is equals to 0 when t minus 3 less than minus 2, and t minus 1 when t minus 3 is greater than minus 2. We have another example when xt is equals to minus e raised to power minus 4t ut minus 2 and h of t e raised to power minus 2t ut. So we need to calculate the convolution of these two signals using the graphical methods. The first step, again, we need to plot x of tau and h of tau, and if you use these two equations you can plot x of tau. So this means that the decay function multiplied with the unit step and the shifted version of the unit step, and then you will end up with this graph. Similarly, you can plot h of tau using this function and the graph will look like this. The second step is that you need to plot h of t minus tau, and before that you need to plot h of minus tau, that is the time reversal and of this signal. So time reversal of this signal will look like this one, and the shifted version of that signal will look like this one, where the shift start from t. And then you need to plot the overlapping and non-overlapping region. So you have these two signals like the x of tau, and then you have that signal that is x of minus tau plus t, or you can say x of t minus tau. So that is this one. So x of tau multiplied by h of t minus tau. So the first one is the non-overlapping region. So non-overlapping region where t is less than 0. So if t is less than 0, so you can see that there is a no overlapping region. So that is why the value of y of t is equals to 0. This other step is that where the overlapping region. So overlapping region when the value of t is greater than 0. The value of t is greater than 0 but less than 2. So then you can calculate y of t, the integral whose limit start from 0 to t, and e raised to minus 4 tau e raised to minus 2 t minus tau d tau. So if you take the integral, then the answer will be 1 by 2 e raised to minus 2t minus e raised to minus 4t. And then you can also have the overlapping region when the value of t is bigger than 2. So again the limits y of t is equals to 0 to 2 e raised to minus 4 tau e raised to minus 2 t minus tau d tau. So if you take the integral of this one, then the answer will be equals to minus 1 by 2 e raised to minus 2t e raised to minus 2 tau, the limit 0 to 2. So if you insert the limits, then the answer of y of t is equals to minus 1 by 2 e raised to minus 2t e raised to minus 4 minus 1. So it means that you have three value of y of t. So y of t will be equals to 0 if t less than 0, and y of t is equals to half e raised to minus 2t minus e raised to minus 4t if t varies from 0 to 2. But the value of yt is equals to minus 1 by 2 e raised to minus 2t e raised to minus 4 minus 1 when t is bigger than